Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Ammar Hakimi bin Khairulmuzzamil from Ammar Simtun Ghafar Baba from Malaysia. The Palfrey has been successfully made to be ours as it has its own IPO ID, which is shown in the diagram here. My project title is the Palfrey. Next, I also found that the foam concrete is brittle in nature. It has very low mechanical and physical strength. So, the idea of Palfrey is to improve these three problems and overcome them to produce a more resilient infrastructure according to the Sustainable Development Goals set by the United Nations. So, we thought, would this and this make the best fusion? The Palfrey was carefully designed with specific fiber to volume ratio that is according to the ASTM standards, which is the American standard for testing and materials. The secret formula of the Palfrey is found within the ASTM standards. Its optimum ratio of fiber to concrete by weight has given it the strength of the current Palfrey. The fiber was first extracted from the leaves before being treated for 2 hours. Then, we air-dried the fibers for 1 day. After drying, we cut the fiber into small pieces and mixed it into the foam concrete mortar. After 28 days, we tested for compressive strength, tensile strength, and flexural strength. The Palfrey we tested were in 2 different categories: the high-density Palfrey and the low-density Palfrey. First, compressive strength. For high-density Palfrey, 7.1% increment is observed when compared to non-reinforced foam concrete. As for low-density Palfrey, 65.5% increment is observed when compared to low-density normal non-reinforced foam concrete. Compressive strength means that more force is needed to force Palfrey to reach its initial failure mode. Normal foam concrete would crumble apart when they reach the initial failure mode. However, Palfrey does not behave in the same manner. Palfrey is more elastic due to the elastic fibers integrated within the mortar. So, Palfrey will not break apart and crumble down when it reaches its initial failure mode. Now, for tensile strength. For higher density Palfrey, an increment of 177% is observed in terms of tensile strength, while for lower density Palfrey, an increment of about 116% was observed when compared to normal non-reinforced foam concrete. This outstanding increment in terms of tensile strength means that Palfrey can withstand a lot more pressure than normal non-reinforced foam concrete along the length of the concrete. This means that Palfrey can sustain more load along the length without reaching its initial failure mode, while for normal non-reinforced foam concrete would have already crumbled down and caused danger to people in the building. Finally, for tensile strength. Higher density Palfrey showed an increment of 150% when compared to normal non-reinforced foam concrete, which is Palfrey of 0% fiber content. You might be wondering, where is the reading for lower density Palfrey? For lower density Palfrey, we are pleased to announce that we have an increment of 292% when compared to normal non-reinforced foam concrete. This means that the flexural strength of a low density Palfrey is almost 3 times better than a normal non-reinforced foam concrete. Higher flexural strength means that more force can be sustained by the Palfrey within its initial failure mode. So, before Palfrey breaks apart, it can withstand higher pressure compared to normal non-reinforced foam concrete. In conclusion, by adding natural fibers into foam concrete, we are able to increase the compressive strength, flexural strength, and tensile strength of foam concrete by almost double the original value. So, this shows that by adding natural fibers into the foam concrete mixture, we have achieved our objective of this project, which is to overcome unused pineapple waste from the pineapple plantation sector, to increase the compressive, flexural, and tensile strength of foam concrete, as well as to change the brittle nature of foam concrete. I think that Pulpcrete is such a revolutionary idea as it opens a new door to sustainable development as well as floating structure applications. The Pulpcrete follows the guidelines set by the United Nations as shown in the Sustainable Development Goals, specifically the 9th and 12th goal. The 9th goal, which is to produce resilient infrastructure by means of innovation, while for the 12th goal is to reduce over-extraction and preventing waste. The Pulpcrete aims to stand tall among other inventions to be conventionally applied within the construction industry. This can be done when we approach the Construction Industry Development Board, CIDB, to suggest the usage of Pulpcrete to other constructors to be used by constructors throughout Malaysia. Thank you.